So the next minor landscape profile that we'll take a look at here is the flatlands. And these are obviously something that is very near and dear to my heart, living in Saskatchewan. I live on a 22-acre property in Saskatchewan, and although I do have a valley that goes through my property, the front 7 acres of my property, that's next to about 7 acres of my neighbor's property, when I was looking at the contour lines of our properties, there's actually less than a 1 foot variance in height over about a 14-acre area. It's very flat. So we're going to look at some of the possibilities that you may have when you're on the flatlands. So they're very shallow in the sense that if there is a slope, which there always is to some extent, it's so shallow of a grade that it's definitely hard to get a gravity fall of water. You have very little head pressure. So if you have a tank somewhere and you want to just gravity feed the water somewhere, you need that tank to be quite a bit higher in order to actually get the water out the other end of the hose. And that is extremely difficult to do on the flatlands because you just don't have that height differential going on. So when you have to build a swale in the flatlands, typically what you have to do is you go down below the ground. So if we look at a typical swale here on the flatlands, we actually have to dig down to be able to even create one whatsoever. So the deeper the swale, the larger the mound you have and the more water you can have backing up. So if we just have a little bit of a hole, a little bit of a swale, we wouldn't have a lot of water filling up in there because we'd have such a tiny little mound. But if we ended up digging a really big swale, we'd have more of a mound and we could actually end up filling more water in here, which would saturate more of that mound and so on and so forth. So there's actually a lot of potential for water collection on the flatlands, and it's very easy to build a large mound in the flatlands because you don't have the slope to contend with. Whereas on a steep hill, if we were to build a swale that looks like this, that mound would likely just end up over time kind of getting washed down the hill, and it wouldn't retain its same size and shape to the same extent. And one of the key benefits on the flatlands that not a lot of people use to its full advantage is the fact that when you dig a hole, you get a mound. You get an excess amount of soil. So when we have a hole for a volume of water on a slope, then you need less soil downhill than you need. Sorry, let's say that over again. So when we look at on a slope, when you have a hole for volume of water on a slope, you need less soil downhill than you need on flat land. So you'll end up with extra material. So on the slope, we need more material down here in order to hold the water on the landscape. On the flatlands, we don't really need much of this mound at all in order to be able to hold the water in here. So we end up with a big pile of extra soil that we can use to our advantage. So for example, if you're building a pond, then on flat lands, you're going to end up with a ton of material that you can use to form the wall for the pond to pack down to make sure that the pond isn't going to leach out into the surrounding area. And the flatter the land, the less material you need to build the wall for the pond. And it costs money and takes a lot of energy to move this extra material, but it creates massive opportunities. Because the flatlands are quite featureless, this excess in material gives us the opportunity to build any sort of feature wherever we want it on our landscape. We can shape the land with a lot of this soil. So on the flatlands, we definitely have a lot of problems with wind. So we need a lot of windbreaks. So one of the ways that we can use this extra soil is to create earth banks, which would just simply be large mounds of soil, which we may have actually gained from digging a pond. And so this pond is now a really good source of water. And as a result of creating this pond, we end up with this earth bank that can provide us some shelter from the wind as well. And if we do it creatively, then we can position this pond in such a way that we have swales that fill the pond, and perhaps we have an earth bank here, and we position our house in such a way that our house is protected from the wind by the earth bank. And we also have the thermal mass of the pond itself, which is creating a bit of a microclimate, keeping everything nice and warm. And these earth banks can be used in all sorts of different ways, because whether you're in a cold, warm, or hot climate, when you have a flatland condition, you can use that earth bank to either shelter things from the cold air so that you create a bit of a warmer atmosphere, or you can use it to help create some airflow where there wasn't airflow before, or you can block it altogether. You can, in this situation, you might get some extra light. The sun is here. You might get some extra light reflecting off the pond into the house as well. So you can vary this from the hot or cold climates simply by changing whether that earth bank is sheltering you from the wind or sheltering you from the sun. So in the dry lands, you might end up having your house up on a tiny little, with a little bit of a grade coming out from it. And then you would have the earth banks kind of going around the house like this. And when you have that kind of an opportunity, then like we saw before, we can be putting some trellises in all around the earth bank to create a bunch of shade. And a bunch of the water is going to, especially gray water, anything like that from the house is going to be coming down here and collecting in here. You can have your gardens in here. It's going to be completely shaded from the hot desert's winds and from the sun itself. And it can almost be like a circular earth bank almost around the entire house, except for just maybe a little bit of an entrance point as well. That kind of shows you how we have a tremendous creative opportunity in the flatlands that we might not have if we have a little bit more of a slope. So on a slope, you would typically plant, this one's definitely going to need a drawing here. So when you have a slope, a typical way of figuring out the spacing of your swales would be when you look at the size of your mature trees that are on this swale, you would almost take a horizontal line, and this would be the positioning of your next trees. But if we look at on a flat land, we don't really have that same kind of structure at all. So when we look at the steeper slopes, the steeper the slope, the more trees you're going to have on it, because these swales can be a lot closer together. And the open and flatter the land is, typically the more spaced out the trees are, but that's just a very, very general approach. So on flat country, though, that doesn't really work in the sense that if we use this exact same methodology, I would have a tree on my property and the next closest tree might be 30 acres away, or that's kind of an awkward kind of, that's an area, not a distance, but I think you get the idea. Like it would be, miles and miles away than the very next tree, which doesn't really work. So when we're on flat land, more so what we're looking for is trying to lift the wind up and over the areas that we want sheltered. It's not so much about the shading as it is about just the redirection of the wind itself, especially if it's cold out. So in that situation, we want to keep in mind that 20% of our land in a very flat landscape with a very windy condition, 20% of that land can go into shelter without losing any of your production. So you've increased the production in the remaining 80% of the land that you have because you've reduced all of that stress on the crop. So you're also looking at where your sun angle is too, because obviously you don't want to be shading too much as well. But in hot climates, you want the shade. And you're looking at more of like a sun trap in a cold climate. So if we think back to that earth bank example and the sun's facing this way and the house is inside, you're really trying to trap that sun and that warm air as much as you possibly can. Going back to the trees and the wind, one opportunity that wasn't talked about very much in my course, and I think it's just because my course was taught by someone that hasn't lived in a really cold, flat climate, is that when we have that much wind and we have almost a difficult time trying to accumulate water by water running down a slope, one advantage that we also have when we have these earth banks or when we're planting these shelter belts is that we can trap snow. And although the volume of snow that you have isn't equal to the amount of water you'll get out of it, it definitely can help. So if you can redirect that snow and accumulate it where it's actually needed, just by planting a bunch of trees in strategic places, that can really work to your benefit. And on the flip side of that, you have to be very careful not to put your lines of trees too close to your lanes or something like that either, because what happens is when the snow comes over, it drops and you'll end up with tremendously deep snowdrifts where you don't want them either. So there's quite a bit of an art to trying to get that spacing correct. And I'll do my best to try and post some links to shelter belt information on the website as well, so that you have a better idea as to how that spacing should actually work as far as sun ankles and trapping snow and things like that. So when you're putting the swales into the flat land, you only need to make sure that the bottom of your swale is flat. So if you have flat land that's kind of undulating a little bit, but overall there's really not much of a change in elevation, you have a little bit more flexibility as to where that swale is going to go, because all you need to do is, if you're digging a swale here, for example, you would just dig it kind of shallow. But if you wanted a swale, if you wanted this swale to go uphill slightly on a flat land, you would just dig the hole deeper so that the bottom of this swale is the same. That does not look the same at all. Is the same elevation as the bottom of another swale. So just by digging more shallowly and deeper, as long as there isn't a huge change in elevation, you can almost make those swales go wherever you want and still have them be on contour, still have the swale completely flat on the bottom, which is it really gives you a lot of creative freedom when you're trying to design your landscape, because you have the opportunity to put those swales in a lot of different ways that you wouldn't be able to do if you have a more pronounced slope. So if we look at the greening the desert example in Jordan, Jeff Lawton had put a bunch of swales in, and the swales were on average 50 meters apart. But because swales are never parallel, because the landscape just isn't that symmetrical and that perfect, in some places, so here, like if there was one swale here, so in some places the swales were like 70 meters apart, and in some places they were only 20 meters apart, but for overall they were about 50 meters apart on average. So where the swales in the Green the Desert project were only 20 meters apart, the area was much more lush and green and productive. And that's because there was a lot more shade cast from the trees on these swales to the next swale. And I almost need a side profile of this. So if you have the swales, we have the trees coming out, they're going to cast shade. And so what happens is if the next one is already here, then there's shade kind of coming in to help shade all of the ground in between these two swales. So not only is there more shade cast where the swales were closer together, but there was a lot less evaporation and less wind, and just better soil catchment altogether when the wind was blowing. And so the soil was richer too. So although intuitively we might think that putting these swales closer together might almost be exhausting the landscape by having too many things in one area, the result in an arid desert-like climate was actually very beneficial to have them closer together. So when we get this extra material in the drylands, when we're building swales, when we're building ponds, every time we dig a hole, we end up with this extra material. Not only can we use it to shape the landscape, but we can also use it for shelter or even to build with it. So if you check out the resource section on the website, I'm going to be putting links to a couple videos here on rammed earth houses, earth ships, recycled tire houses, and earth bag houses and domes as well, so that you can kind of see some different methodology in how you can use some of this extra material in order to build structures with it.